So today we're going to be talking about ocean currents. What do we need to know about ocean currents? What do we already know about them? What conditions do we have to have around the globe and over the oceans for these currents to develop? And what keeps them moving? So make sure that you have your note sheet out and you're ready to either write on them or highlight them or circle important information. So let's just get a big overview of ocean currents first. So ocean currents are really just the moving of water. So it moves around in a certain pattern. So we see there's some red marked on here, and those are going to be warm currents. There's some blues. Those are going to be cold currents. And then there's some in-betweens. A lot of those black ones are now mixing with the hot and the cold. So they're kind of an in-between, either a cool or a warm current. And you can see these are surface currents, and they're located all over the world. And generally, you can see the pattern that they're moving in circles. So what exactly are currents? They are a large stream of water that flows through the ocean. There are two different types. One is your surface current, and one is your deep currents. So surface currents are going to be in the top 10% of the water. Okay, so they're not going to extend down very far, and they're going to be going around and around, kind of in that circular motion. Deep currents, on the other hand, are very deep. They're going to be circulating by convection. They're going to be getting hot and kind of rising and moving, and they're going to be getting cold and kind of sinking and moving. There's a big difference. If you can see surface currents, there's lots of them. And when you look at deep currents and you follow the pattern, there's really only one deep current. It's the world's big conveyor belt. And it's how deep down that water, warm water and cold water, gets moved around the world. So surface currents are rivers of water in that top layer, that top 10% of the ocean. The surface currents are determined by several things. The wind direction. So if the wind is blowing from the east to the west, the currents are going to be flowing from the east to the west. They go with the wind, not against the wind. The Coriolis forces the Earth's rotation. Okay, so as the Earth rotates, it's going to be pulling it a little bit. So if you think about the Earth rotating, as it does that, it's moving in a counterclockwise direction. So it's going to be pulling those currents just a little bit in that counterclockwise position. And the position of the landforms makes a big difference, because when currents hit the landform, they have to reflect or go back. And that's what kind of causes those circular motions. They can't go through it, they can't go under it, and they can't really go over it. So what's causing the surface currents? Well, surface currents are driven by the global wind system. Your key word there is the global. So we know a globe represents the entire Earth. So the global wind systems that are fueled by energy from the sun. So we're going to learn a little bit about different sections of our globe. Okay, so one section is right there at the equator, and it's called the doldrums. And there's like no wind. Okay, there's not a lot of heating and cooling there because it's kind of hot there all the time. So in different sections, you're going to have different wind systems because of the heating and the cooling of the Earth. And that's going to drive the currents. Because remember, as the wind blows, the current goes with the wind. So some of the ones we're going to talk about are polar easterlies. So this is flowing east to west. So the water would be going east to west. The prevailing westerlies, west to east. So the current's going to go west to east. And we've got our trade winds and several other things that we're going to be talking about. And then we also have the Coriolis effect. It's the curving of the winds that's going to cause the curving of the currents. And it's not turning, it's just pulling a little bit. Like if you were to push back in your hand right in the middle, it would go back and your fingers might come forward a little bit. So it's the curving. The third thing is the continents. Well, they get in the way, okay? When the currents hit them, they reflect or they deflect, they bounce back. But as soon as they get back out into the ocean, they gain more momentum again because you've got the winds out there, and it keeps them going until they hit another large landmass. When they hit it, they deflect, they go back out in the ocean, they got to go somewhere, they move with the wind, they get all the way over there, they hit. So it's really creating this big circular movement or giant circles in the large bodies of water. And we call them gyres because there's a gyroscope that's always moving in circles to keep a balance, and that's where it comes to the gyres. It means big circles. And one of the things that was created, which is not so good, from these gyres is the Great Pacific Garbage Patch, because it's encircled an area in the Pacific, and in that big circle, it's gathered a lot of garbage. You can see here one of the biggest gyres. It's the North Pacific gyre. So it's bouncing off the United States, going back over to Asia, bouncing off of Asia, coming back, and it's a round and round. It's a continuous motion. So that continuous motion continues to draw in and keep the garbage trapped. Because if the garbage tries to get out, it's pushed right back in by that current. So it's created this giant garbage patch. You can see there's a man trying to get through it in a canoe, but it's hard to get through because there's so much garbage. We are really harming our earth by putting so much garbage into our oceans and streams. So let's take a look at the map. Which surface current is off the coast of Georgia? Well, first we have to find North America. And then the easiest thing to find on North America is Florida. We know we're right above Florida, so we're going to look for the surface current that's closest. And there is a warm current off our coast, and it's called the Gulf Stream. So when we talked about things that influence climate, one of the things we talked about was currents. And we know that a warm ocean current is going to bring overall warmer weather and a warmer climate. So you can see here the eastern coast of the United States has the Gulf Stream passing by, which is going to bring warm water from the equator because our warm water rises. It's going to be rising from the equator and moving its way toward the poles where it will get cooler. Our deep currents are, I won't say the opposite, but they're a little bit different. They are slow moving currents and they're very deep. So they're down below that top 10%. Many people call them the Earth's conveyor belt. A conveyor belt is a long connected belt that you put things on and it takes it to somewhere else. So basically this big conveyor belt, we're putting on warm water and we're moving it somewhere else. It's cooling down and we're moving it back. So it's really just like you're going to the airport and you're trying to get your luggage. This is that big luggage carrier under the ocean that's carrying water instead of luggage. So we can see it's carrying warm water around the equator in that area. It's moving up toward the poles, so it's increasing in latitude. As it gets up here, it starts to cool, so it starts to sink. The two things that are the main factors here are the temperature of the water and the salinity of the water. They control the density, which makes the conveyor belt work. So what causes those deep ocean currents? Well, the density, temperature. We know warm air rises, so warm water rises, just like the warm molten rock in our mantle rose, and then it cooled and it fell. So as the warm water rises, it starts to cool, and then it's going to sink. It's going to warm up and it's going to continue that over and over. Our warm water is rising. It gets warm and then it cools and it falls. It's this continuing convection. Remember, when it loops and loops and circulates, it's called convection. And that's how it's going to be moving. So what causes those deep ocean currents to really move is that difference in salinity. Remember, I just mentioned salinity and temperature. Well, salinity is the more salt there is. So think about it. We've got more matter in the same space, the more dense it is. So it's going to sink. Then the less salt, the less dense. It's going to rise. And that's when it's going to make the water move. When we combine the more salt with the less salt, that water moves. Because we know the more dense, it's going to sink. Then it's going to go down. It's going to get less dense. It's going to rise. It creates this continuous movement. So currents are wonderful. They move water all over our earth. They keep our water moving, our water sources moving. They bring warm to some areas. They cool off some areas. But currents, sometimes we think, ooh, that's not such a good thing. The Gulf oil spill was a good example. So 800,000 gallons per day was spilled, and that had to go somewhere. So if that spill had continued, there would be enough oil in the pocket to last for 7 years. So thinking about currents, did that oil stay in one place or did it move? It moved. So you can see what the oil did. Current started making it move. And it moved it further and further because it's going to move it along with the current. It's going to bounce when it gets to the next large continent, and then it's going to come right back. So instead of being able to clean up an oil spill in one place, if we don't get it quick enough, it's going to encircle a whole area, polluting that whole area of our ocean. So sometimes currents can be fun. Currents will move anything that jumps aboard. So we read a little bit, or we watched a little video about that cargo ship that spilled all those rubber duckies. They certainly didn't do it on purpose, but it happened. And those rubber duckies started riding the currents. And you can see they ended up all over the world, even though they were spilled in one place. They jumped aboard a current and they moved with that current. They ended up on all 7 continents after they rode all the different currents. Now think about it. Were they riding surface currents or deep ocean currents? Well, if they were staying on the surface of the ocean, they had to be riding our surface currents. So let's take a look. We've got a word bank: convection currents, salinity, heat, equator, density, temperature, and saltier. Let's see if we can figure out what finishes this sentence. Deep ocean currents. So I know it's going to be deep in the ocean. There's going to be one of it, and it's called a conveyor belt. They're caused by the differences in the blank of the water. Well, let's see. Well, I know it's not a convection current because it's deep ocean. And we talked about salinity, and that changed some things. But salinity and temperature, wow, when we put those together, it created differences in density. And when there was more and less salt, that created more density and less density. So it makes sense that the density is what's really moving that ocean water. The density of the water depends on its, well, it wouldn't be convection currents. Salinity, oh, we learned that in our presentation. The salt, more salt there is, the more dense there is. The less salt, the less dense. Heat and temperature are kind of the same. That would be hot, but really the changes in temperature. So I think the density of the water depends on its salinity and its temperature. As deep ocean currents reach the poles, that would be the North Pole and the South Pole, and I know as I increase latitude, it gets colder. So the water cools and it gets, I think it's going to get saltier, because when it's cooling, it's not moving as fast. It's going to slow down. It's going to clump together. So I think it might be getting saltier, which makes it denser, causing it to sink. If it's denser, I know it has to be saltier, because less dense is less salty. The cool water then flows from the bottom of the ocean back to the blank where it is warmed again. Well, where could I warm water? Well, the best place to warm water would be somewhere that gets a lot of sun. And I know that a lot of sun directly hits my equator, because that's my 0 latitude. Once it's warmed, it starts what all over again? Well, does it talk? Let's look at these. It doesn't really start the heat or the density again, but convection currents, I know that are always moving. It's circulating. So it must be starting my convection current all over again. And that is the way heat is distributed around the globe, because we're moving heat up, gets dense and cold and saltier, and it sinks. It starts moving down, it warms up, it gets less dense, less salty, and it's a continuous cycle. If you have a little time at your table with permission from your teacher, discuss some of these. Remember, stay on topic and make sure that you're explaining your answer given some of the notes that you took.